All right, so when we're given a polynomial, this one f of x is equal to ax cubed plus bx squared minus 16x minus 4. When f of x is divided by x plus 1, the remainder is 4. And it's also known that x equals 1 is a 0 of the function. It wants us to figure out what the values are of a and b. So we are going to use both of the pieces of information with our polynomial to go ahead and set up a system of equations to solve this question. So the first one, it says that when it's divided by x equals 1, the remainder is 4. So I'm going to use the remainder theorem here. So that's going to be x is equal to negative 1. I'm going to go ahead and plug that in for x in my polynomial, and I'm going to set it equal to 4 because it tells us that that is the remainder. So I will have f of x, which we said was 4, is going to be equal to a to the times x, which is now going to be negative 1, to the power of 3 plus b times negative 1 squared, because x squared, minus 16 times negative 1 minus 4. So now I go ahead and I simplify this. So 4 is going to be equal to negative 1 cubed, which is still negative 1, or negative 1 times a. Then I'll have negative 1 squared, which will give me a positive 1 times b. So that's just going to be plus 1b. And then negative 16 times negative 1 will give me 16. And then minus 4 is still going to be the same. So now I'm going to combine like terms. So I'll have 4 is going to be equal to negative a plus b plus 12. And then I'm just going to now subtract 12 from both sides. So 4 minus 12 is going to give me negative 8 is equal to negative a plus b. All right. So that's the first half. And now I'm going to basically repeat the same exact thing. But it also says now this time when x equals 1, that's going to be a 0. So when something's a 0, I can go ahead and then set that equal to 0. So I'll do the same thing again. So 0 is going to be equal to a times 1 cubed plus b times 1 squared minus 16 times 1 minus 4. So then, again, I'll simplify it. So 0 is equal to 1 cubed, which is 1 times a, so just a, times b times 1 squared, which is still going to be 1, so a plus b, minus 1 times 16, which is 16, minus 4. Combine like terms again, so 0 is equal to a plus b minus 20. So that means 20 is going to equal a plus b. So now I have my two separate equations, and I'm going to turn this into a system. And I'm going to solve this by using substitution, okay? So I'm going to set my first equation. I'll set that one equal to b, because that will require the least amount of movement here. You can also do the same thing with the other equation. I just personally believe this is easier for me. So I add a to both sides. So then I'll get negative 8 plus a is going to equal b. And so now that I know that one of these is equal to one of the variables b, I'm going to take this b here and plug x or negative 8 plus a in for b in my second equation. So when I go ahead and I'll do that, I'll have 20 now is going to equal a plus, like I said, I'm going to go ahead and plug this in, negative 8 plus a, and then I'll go ahead and simplify that. So 20 is going to equal 2a, because a plus a is going to give me 2a, minus 8. So I go ahead and I subtract 8, or not subtract 8, add 8 to both sides. So that will give me 28 is going to equal 2a. Divide both sides by 2. So I'll get 14 is equal to a. So that goes ahead and gives me half of my solution because it's asking for a and b. So I'm just going to take this 14 is equal to a now and plug that in for a here to figure out what b is. So I know 20 is equal to 14 plus b. And so then just solving that one, that means that 6 is going to be equal to B. So my answer to this question is going to be that A is equal to 14 and B is going to be equal to 6. Again, I'm using this using the remainder theorem as well as systems of equations.